Okay, so we're back for part two. And we're looking at this graph. We kind of spoke about this. I shouldn't, we haven't got this line here yet, but we're going to have. And if we read the question, a resistor has a resistance of 4 ohms. Draw a line on the graph above to show current through it and the voltage across it up to 12 volts. Okay. So first thing we need to do is to get our current value, because on the side it says there current, voltage. It gives me the resistance, which is fine, but I haven't got a current. So that's the first thing I do, because it's worth 3 marks. So I'm going to use my equation, V equals IR. I don't know my I, so it's V over R. So my voltage is 12 volts, my resistance is 4. It's going to give me 3 amps. So I know I can go to my graph now, and when it's 3, okay, it's going to be 12. And I can just draw a point there, okay, because I know when it's 12 it's going to be 3. And then I'm going to draw my line back to 0. And that's what gives me my voltage current graph there. So a resistor has a resistance of 4 ohms. Draw a line on the graph above to show the current through it and the voltage across it up to 12 volts. So that's what that 3 marks is worth there. And then the last bit of this question says, use the graph and an equation from page 2 to find the power of the lamp where it has the same resistance as the resistor. The same resistance as the resistor. Remember now, the resistor, I've just done the line for. It was a nice straight line. The lamp looks like this. And it wants to know the same resistance as, so it's basically the crossover between the lamp and the resistor there. So if I draw a line up from, I can draw a line down. It's going to give me 9 volts. And a line across is going to give me 2.25 current, amps. And then I can go to this page and I can work that out. In fact, I've done a power one there. Why have I done it? Because it's asking me to find the power, not the resistance this time. So I know my current, I know my voltage. My current is 2.25. My voltage, is 9, and that is going to give me 20.25. Sorry, I had a bit of a moment then. But yeah, that's why I used that, because I assumed it was going to be asking me the resistance, but it's asking me power this time, so I need to use that correct equation. It says there, compare the resistances of the lamp and the resistor when the voltage is 12 volts. Give a reason for your answer. Well, I've said, if we look at the graph, the lamp there's less current at 12 volts running through it than there is for the fixed resistor. So the lamp is going to have a higher resistance at this point, and the fixed resistor is going to have a lower resistance. So what have I actually said? I said the lamp has a greater resistance there and less current at this point. So that is literally just, identifying that the fixed resistor has got more current at this point than this one, because it is current on this side. This is current. Usually it's say on the side, but in this case it says at the top there, like current. So that's that one. And that was that page. Nice little page there. Oh, I've still got quite a bit to do. This might be a 3-video job. A group of people set the following circuit to investigate how... Oh, look, I've got another standard test circuit here. I've got a fixed resistor there. I've got a lamp. I've got an ammeter. And I've got a power supply. Although I haven't got a variable resistor. Not a variable resistor this time. So let's have a look. Draw a voltmeter across the circuit. Well, we've done this before. Voltmeter's got to go across the bulb, and it says there across the lamp. So that's 1 mark. The slider on the variable resistor has been moved to the end of Y. So it is a variable resistor. Okay, so maybe I should have read the question. So state what effect this has on the current through the lamp. So if it goes this way, then the current's going to decrease. If you max this resistor out, it's not going to allow anything through. It's not going to allow anything through. So it will decrease as you move to Y. State what effect it has on a voltage. Well, it's going to have the same effect on the voltage. The resistance. If resistance increases, then voltage and current decreases. If resistance decreases, then voltage and current is going to increase. Here's a set of results here for current against voltage. Oh, lovely. I'm gonna gain marks here. How many marks is it worth? I don't know yet, but we're looking for these. We're looking for these ones because we like plotting, and it's even giving us a scale. Like, it's even giving us the scale. That's all we got to do is plot and draw that nice little curve, because we know it's for a filament lamp. Look, so it's going to take that shape. It's not going to be like a fixed resistor where it's a nice straight line. It's gonna tail off, because the more heat it gives off, the less current, the more resistance. It's going to sort of flatten off, unlike that fixed resistor which goes all the way up. So there's my graph for 2 marks. Use the equation so this is a foundation question because it's giving you it. To calculate resistance of the lamp when the voltage is 8. So when the voltage is 8, I've just drawn my line up, look, from 8, the current's going to be 3. I can use that nice little equation, V over IR, cover R, V over I is going to be 8 over 3, 2.67 ohms there. State how the resistance of the lamp changes as the voltage increases. As the voltage increase, I've said it does not follow Ohm's law. It's not directly proportional. The gradient decreases after around 4 volts, which it does. So there's my 4 volts. Okay, so a nice straight line until you get to there, but then it's like starts to heat up then. The resistance gets more, therefore the current starts decreasing. More resistance after 4V. Okay, how many marks was it worth? 2 marks, so I've put 3 good points there. Let's have a look at this one. Is this one before that? Yes. And then homework 5, a student set up the following circuit. Oh, is this another standards? No, it's not this time. I got 2 lamps, 2 amps running through it, a voltmeter going across. This looks like a foundation. Use the information above and this equation. Well, there we are. It's just standard. Okay, your voltage is 4, your current is 2, because current is the same everywhere throughout that circuit. Use the information above, and now we're going to use power. So our voltage was 4, our current was 2. I'm just times them to give me a power. In fact, these are really, really easy questions, okay? Unlikely to come up, but they're there anyway. State the current through lamp 2. There we are. Well, the current through lamp 2 is, because it's a series, it's going to be 2 amps. It's going to be 2 amps everywhere there. And then the next one is another nice, easy question, I think. The student adds another lamp in series with lamps 1 and 2. Choose the words from the box below. Each word and phrase may be used once, more than once, or not at all. Okay. When an extra lamp is added, it causes the current through the lamp. It's going to decrease because you're adding more resistance. But the battery voltage is going to stay the same because you're not adding any more batteries. So be careful there, because I know I've said as the current decreases, then voltage decreases. As the current increases, the voltage increases. But the battery voltage, look, it's the battery voltage. You're not adding any more batteries, so it's going to stay the same. It's going to be the same amount of push, although there will be less voltage through it because the current. Let me rephrase that. The bulbs will be dimmer because there's less current, because you're adding more resistance. But the battery voltage, the voltage coming from those batteries, is still the same. But when you measure the voltage across those lamps, they will decrease. Because remember, in a series circuit, the voltage gets split and then it adds up to that battery voltage, or the supply voltage, we say. 3 marks there, surprisingly. In a house, the lamps are connected in parallel. Well, we've had this question before. What's the benefit of parallel? If one bulb breaks, the other still works. The same voltage across each branch, so the brightness is going to stay the same. And you can even add switches on each branch. Now, I'm nearly coming up to 12 minutes for this video. I'm going to kind of race through this. or I might even leave this and put it in another video. I think that's what I'll do, probably, unless YouTube will let me upload this. So I'm just going to put a marker here. So as we get to 22 minutes, I'm just going to put a marker. So on 20, the filament lamp X and Y are connected in series. Lamp Y is brighter than lamp X. All right, so here we go. This is unlikely to come up, but I'm going to do it anyway. Choose and write down an equation from page 2 to explain why Y is brighter than lamp X. Consider power. There's a hint. Right. So, not that we go into it too much, but what we do on this bit, so series circuits, the current is the same throughout. So current's not going to change. That's the one thing that when we do an equation, we can use this equation to show how this is brighter than that. We know that this is the same. So current is our sort of control, if you will. So series circuit, the current is the same. In a series circuit, the bulbs will more resistance will draw with, I think that should have been, bulbs with more resistance will draw more voltage and become brighter. So if it's got more resistance, it's going to draw more voltage. Therefore, they will become brighter. But we need to show this down here. Y has a bigger resistance. Therefore, it will draw more voltage compared to X. So Y, you will need more power. I've used the voltage equation and the power equation just to show you how you can show that. Remember I said current is the same. So I equals V over R. So if I keep that and I choose a number, I'm just choosing 12. I could have chosen 6, I could have chosen 20, but 12 is nice. Well, I just chose 12. I don't know why. I'll show you how I'm going to work this now. When you're doing division, the number that's being divided is kind of always on bottom. So what that's saying is 1, and I know that looks like 18 there, but this is 12. 1 goes into 12 times. Or I can say 2 goes into 24 12 times. Or I can say 3 goes into 36 12 times. You see, it's always going to equal 12. But as the voltage increases, so does the resistance. As the voltage increases here, so does the resistance. So my point is, as the resistance gets bigger, it's going to draw more power. And I'm going to prove that to you here. Again, I'm going to use a fixed value for I. I know it's squared, but it doesn't really matter what value it is. You don't have to put the square root, or you don't have to square this number at all here, because it's a fixed value. I'm going to just show you how power increases as resistance increases. And I've used the same values. 1 is going to go into 12 times. 2 is going to go into 24 12 times. 3 is going to go into 36 12 times. So what does that mean? It just means that as you increase that more resistance is going to take more power. Okay, and we've demonstrated that more resistance is going to take, so more voltage is going to take more resistance is going to take more power. That question really is all about why this is brighter than that. It's because it's got a bigger resistance, and that's pretty much the question. Although for 4 marks, it's a lot of work, a lot of head work, and yeah, I think I'll leave it there. Hopefully that'll all fit on YouTube. If it doesn't, then it's going to get lost.